Yes, now let's see about averaging and weighted averaging. And here this slide shows the actual values and the predicted values of three models. We are not focusing on any kind of the input data set or training data set or testing data set. We are just showing the actual expected values and the predicted values of three models. And obviously it is a regression problem because it is not a categorical value. So the three models are giving different predicted values. So for example, the model 1 may be of least square method, or the second model may be of Bayesian regression, and so on. So every model, the three model provide three different results. So we are going to take an average of the results produced by each model. So on taking the average, we are getting some value. So this is the final output instead of showing any of the three outputs. So the final average result is a predicted value. If you want to perform any mean absolute error or root mean square error or MSE, we have to focus on this actual value as well as the predicted value. The next is weighted average, and we need to give more weight on the model which is performing well. So how to identify the performance of the models? So we already know about R square value, which we have seen in ordinary least square method, OLS, in stats model, using stats model package, right? So we have three models and we are determining the performance of the three models based on the R square value. So the R square value of model 1 is 0.6 and R square value of model 2 is 0.4 and R square value of model 3 is 0.7. And we know the value of R square which is closest to 1 is good. So we can conclude that the model 1 and model 3 are better when compared to model 4. So higher weights can be assigned to model 1 and model 3 rather than model 2. So I am going to give some numbers for better models. So weight 2 is given for model 1 and model 3, and weight number 1 is given for model 2. So let us go back to the same problem, and the actual values are there, and the three models we have, and the three models provide the separate three different results, and we have identified the performance of each model, and we have assigned the weights for those model 2. So 2, 1, 2. This is model 1, model 2 and model 3. Now what we have to do is we need to multiply the values. We need to multiply the values of first model along with the result. So we know the result of model 1 is 3900, and what is the weight assigned to the model 1? It is 2. So multiply the predicted value with the 2, and similarly repeat for all the steps. And here it is 1. The weight of the model 2 is 1. So there is no change in the values. You could see the same column is repeated here. Same column is repeated here. Similarly, for the predicted value 3, we have assigned the weight 3. So the model 3 values 3, 500, 500, 2600, everything should be multiplied with 2, and it is producing the result. Here, while taking average, we should not divide it by 3, we should divide it with the weights. So sum up all the values and divide by the weight of sum of the weights, and we'll get an average. So this is the predicted value. If you want to calculate the mean square error, we need to find difference between actual value and the prediction value, and we need to square it. So this is the actual value 3735, and the predicted value is 3560, and we can perform any of the error calculation methods.